Let's take a look at number 25 from the section 2.1 homework. So we want to find the y coordinates of the points that are 5 units away from the point 1, 3 that have an x coordinate of -3. So we want the points of the form -3, y such that the distance between -3, y and 1, 3 is 5. So we're going to need the distance formula. That's what we're going to use. Remember that formula said that whatever our distance is, let's call it d in general, it is the square root of the square of the difference, x2 minus x1, plus the square of the difference, y2 minus y1. So our 2 points give us these coordinates. We'll let x1 equal -3, and we will let y1 equal to y. And we could have just as well let x1 equal 1 and y1 equal 3. And since we made the choice we made, we're going to let x2 equal 1 and y2 equal 3. So our distance then, filling into the formula, is the difference between 1 and -3 squared plus the difference between 3 and y squared. All right, now since we're squaring, it really doesn't matter what order these subtractions are in. If we change the order, we just get the negative result. So it doesn't matter which point we make x1, y1, and which point we make x2, y2. So 1 minus -3 is the same as 1 plus 3. So when we square that, we get 4 squared. When we square 3 minus y, first time first is 9. Outside time outside is -3y. Inside time inside is -3y. And last time last is y squared. So when we combine the like terms, we get 9 minus 6y plus y squared. Now remember, we wanted this distance to be 5. So we wind up inside the radical with 16 plus 9 minus 6y plus y squared. And if we add 16 and 9, we get 25. And then I'm going to change the order. I'm going to put the y squared first, the minus 6y second, and the 16 plus 9, which equals 25, last. And in order to solve this equation, I'm going to square both sides to clear the square root out of the problem. So I square 5, and I'm going to square the square root of y squared minus 6y plus 25. Now 5 squared is 25, And when I square a square root, I simply get what's inside of the square root, or the radicand. That's what's inside of a square root, or any radical is called the radicand. So I get y squared minus 6y plus 25 when I square the right side. Let's get a 0 on one side of the equation, and we're going to do that by subtracting 25 from both sides. So I wind up with 0 equals y squared minus 6y. I want to use the factorization of that right side. I get y times y minus 6. And the zero product principle says in order for a product to be 0, either the first or the second factor are equal to 0. So that in this case, that means either y is 0 or y minus 6 is 0. So our y coordinates then, when we solve y minus 6 equal to 0, we get y equal to 6. So our y coordinates are 0 and 6.